various standard process. So first process is constant volume process. For constant volume process is value of n equal to infinity. Now check this equation and check this equation. If I prefer this equation, is my del q is as good as du. If I to solve this equation, then I have to solve two independent. So it is better to use this equation. Why? Because my dv will vanish and my equation becomes simple. So it is better to write del q equals to what? Simply du. If it is an ideal gas, can we write du equal to Cv into dt? If it is an ideal gas. If it is not an ideal gas, then we can't write this. So according to this is ds equal to del q by t. Del q is Cv dt. Is it divided by t? And is it ready for integration? So we'll go for integration. So Cv, is it ln T2 by T for constant volume process. Okay, next process is constant pressure process. For constant pressure process is n equal to 0. Is the partial derivative of dP is 0. So is it a second form is better? So can we write del q from this form is equal to dH? And if it is an ideal gas, remember I say ideal gas. If it is not ideal gas, then you have to stop at dH only. Only in case of ideal gas we can write Cp dt. So by first definition of ds equal to del q by t. Del q by t is same as dp dt by t. Integrate. Again we cannot take t common, so is it delta s equals to Cp ln T2 by T1. In addition to this, one equation that you are again familiar is ideal gas equation, which is given as PV equals to what? RT. This is for specific volume. PV equal to RT. Every time you can use this equation for ideal gas. So let me have the third process, that is isothermal process. For isothermal process is value of n equal to 1. That is my temperature is constant. Now for isothermal process is the value of du. Now suppose we want to find out for isothermal process, any of the equation you can select, your answer will not change. Let's prove this. Suppose I select my first equation and my process is isothermal, so I have to force du equal to what? 0. So I can write del q equal to what? P multiplied by dv. My definition of ds is del q by t, which is equals to what? P dv divided by t. Is my p by t from this equation? P by t is it same as r by d? Equation is ds r dv. But R is gas constant. So can we take out gas constant outside? So this one is delta S R. Is it ln V2 by V1? This I demonstrate using my first equation. Now I will demonstrate the same by this equation also. So I am using this equation and we'll check out we come to the same result or not. So this time del Q equals to, what is dH for constant temperature process? 0, because this one is CPDT. So my answer is minus of VDP. My ds is del Q by T. Del Q by T is minus VDP divided by T. Minus V by T from this equation. V by T. V by T is it R by P? Minus R dP by P. this is ds. So we can integrate. This one is delta s. Minus sign is outside. R is constant. Is it ln? Is it P2 by P1? This one is minus. Minus, we will interchange this sign. Then is it become plus? So what I get? This is delta S equals to R ln. Is it P1 by P2? My process is isothermal. So can we have P1 V1 equal to what? P2 V2. That is V2 by V1 is same as P1 by P2. So is this equation and is this equation are one and same. We have done the constant volume, then we have done the constant pressure, then we have done the isothermal. Three standard processes are already over. The third process is reversible adiabatic. Yes, del Q itself is equal to 0. If del Q is 0, numerator is 0. If numerator is 0, then is ds is 0. If ds is 0, then is S1 is same as S2. That is why it is called as constant entropy process. Isentropic process. Polytropic process. Entropic process is represented by PV to the power n equals to constant. In the polytropic process, we do have heat transfer, we do have change in energy, and we do have the work done also. So all quantity are possible. Either in constant volume process, your dV is 0. For constant pressure process, your dP is 0. For isothermal process, du is 0 and dH is 0. But in this case, nothing is 0. So you are free to use this equation. So when you use the first equation, del Q, and we are applying for ideal gas, then can we replace Cv du by Cv dt? This term I will write as it is P multiplied by dV. Now check my derivative term. This term is differentiable in terms of T. This is a differential in terms of V. If I have to find out any problem, if I have to find out entropy change for polytropic process, and I know two temperature condition and two volume condition, I will prefer this formula. We have ds. ds equal to del Q by T. Cv dt by T plus P divided by T multiplied by dV. So ds equals to Cv dt by T plus ideal gas equation P by T R by V, R dV by V. Ready for integration. Your final equation, the final temperature, initial temperature and final volume and initial volume. So if you are available with this data, this is the best equation. So let me continue here. Del Q equals to dH. Can we write dH equal to Cp dt? So this one is Cp dt minus VdP. So this equation I have written this. Now clearly it indicates give me that if I have two temperatures and I have two pressure, so this one is best equation. So by ds equals to del Q by T Cp dt by T minus V by T dP. Again V by T you can replace by gas equation. V by T is same as R by P. So ds Cp dt by T minus V by T R dP by P, that is delta S after integration. Cp ln, is it T2 by T1 minus R ln, is it P2 by P1? So when this equation is useful, when we have T2 T1, P2 P1. But how you identify? You can identify from the very first step. What is DH? DH is basically Cp dt minus VdP. So only concentrate on dt and dP. Check your data, use proper equation and then integrate. We have one more equation for polytropic process, that is del Q equals to gamma minus n upon gamma minus 1 into W. If I want to write down again in a differential form, this equals to what? Del Q. This is gamma minus n gamma minus 1 multiplied by W, and this one is for non-flow, so can we write dV. So when this equation is useful, if you have only V2 and V1, then you can use this equation, provided we should know value of what? N. So what is ds? Del Q by T. Del Q by T is gamma minus n gamma minus 1. This is P by T multiplied by dV. What is P by T? As usual, R by V. So is ds equals to R into dV by V. Now is ready for integration. All these terms are constant terms, can be taken outside. So delta S is gamma minus n upon gamma minus 1. R is here. R is common. And dV by V, is it ln V2 by V? So even you only know the two volume changes and you know the process index, can we able to find out delta S very quickly. So Cp minus Cv by Cv equal to what? R by Cv. This is gamma minus 1 R by Cv. So this equation can be written as delta S gamma minus n into Cv into ln. Is it P2 by P1? Into V2 by V. So we have a TS plot where we have a phase change. On this side we have a liquid. On this side we have vapor state. And this side we have liquid plus vapor. This one is called as constant pressure line. All values of entropy are measured with reference to this origin. Is normally represented by suffix letter having F. So this property from here to here is called as SF, and you should read like this: entropy of saturated liquid. This point is written as G, and this property from here to here you have to read as entropy of saturated vapor. The difference between Sg and Sf is this one, that is called as SFG, entropy of vaporization. What is your observation about this graph? If my pressure will decrease, so is the value of SFG will increase. SF will decrease, Sg will increase. But what is the value of SF? If my graph is at this one, that is it decreasing? SF increasing, Sg decreasing, and SFG decreases. So as the pressure will increase, is the value of SFG will also increase, decrease? Objective question. Pressure increases, the value of SFG decreases, SF increases, and Sg decreases. Is F2G, is it a constant pressure process? Since we have a constant pressure process, is this equation is useful? So can I write equals to dH. But remember, I don't have a permission to write dH equal to what? Cp dt for this phase, because this is a phase change process, and during phase change we cannot define Cp. So my ds equals to del q by t, del q by t, h by t. Limits are f to g, f to g, f to left hand side I have a point function, so it's a simple integral of sg minus sf. On the right hand side is my temperature is constant for f to g process. Take it outside, so this is 1 upon T sach. Then is it simply integral of dH? So is this value is hg minus hg. This value can be written as sfg. Then this value is written as hfg divided by T sach. Universally true in Kelvin. Okay. Now let's consider here this point. This point. Is this point is a superheated point? Is this point is in the superheated region? So I will just call this point equal to what? Sup. Now tell me, is G to sup, is it a constant pressure process? From vapor to superheated vapor, is it a constant pressure process? But during this process, the temperature is variable. So if I want to find out what is my entropy for superheated steam, so this time I have to integrate from G to sup. G to sup. Again, G to sup is my constant pressure process. So is my, this equation is the best equation. Is it G to sup d sup equals to, this is 0, because the process is what? Constant pressure. Can we write dH? Del Q equal to what? dH, and is divided by T, integral of dH by T, sup or G. G to sup, is the phase change occurs or phase change does not occur? So do you have permission to write dH now? And we should write this equals to Cp, but is it a vapor quantity? So Cp of vapor multiplied by dt divided by T. Lower suffix is G, upper suffix is sup. So integration of left hand side is S sup. On the right hand side I have my integration is with respect to what? Dt. My integration is with respect to what? Dt. So I want limit of T. Now check my point T. Check my point G. At point G is the corresponding temperature T sach. So this is replaced by T sach. And at my sup is my corresponding temperature is T sup. Simply T sup. So this equals to Cp of vapor. Is it ln of T sup sach? So what is S sup? Hg plus Cp vapor. Is it ln? So let's consider here one point. This one is sub point, subcooled point. So is the temperature of this subcooled is lower than, and is the temperature of T sup is more than T sach? The difference of T sup minus T sach is called as degree of superheat, and difference between T sach and T sup is called as degree of undercooling. Degree of undercooling, degree of superheat. Right. F to G is called as subcooling process. G to sup, superheating. Sup to G, de-superheating. G to sup, superheating. boiler. Soup to G condenser. D superheating. F to G, sorry, F to sub cooling. Sub to F heating. Okay. So limits sub to F equals to constant pressure process. So again we write dH because dP is 0. So dH divided by d. For sub, this one is F. Is F to G, F to sub, is it a single phase? Single phase. You have permission to write dH equal to what? Cp. Phase change, no permission to write integral. This one is Cp. Is it Cp of liquid? Is it Cp of liquid? Cp of vapor multiplied by dt divided by T. My integration is done with respect to T. So at sub, my temperature is, this one is sub, SUB, subcooled. This one is T sach. We assume Cp liquid constant. So your equation is SF minus S subcooled liquid equals to Cp liquid constant dt by dt. Is it ln? Is it T sach by T sub? Condition: since we are using a thermodynamic equation, all temperature must be compulsorily calculated. Now this is a soup. So what is sub? So sub is it SF minus Cp liquid T sach by T sub. If you go to this side, थोड़ा board check करेंगे. If you go to this side, so is it a positive direction of given axis? So that is why positive side. If you go to the left hand side, is it negative sign? Justified.